Introduction to Microprocessors, Embedded Systems Development, Lecture 6. So far, we have covered different instructions of the assembly language in AVR. So we have seen the addressing modes that we can use the different registers and the constants and the indirect, direct addressings and so on. And we have seen deeply how assembly language is used in order to program the AVR microcontroller. Now, in this chapter, we are going to talk about an alternative because rather than using assembly, we can also use high-level programming, and this is C. So why C? That is the question that we need to ask first. Now, when you think about it, compilers produce hex files that we download into the flash of the microcontroller. Now, the size of the hex file produced by the compiler is one of the main concerns of the microcontroller programmers. This is because we have a limited on-chip programming memory. Now, we have to think about how the choice of programming language will affect the compiled program size. Okay, let's compare two languages and find out pros and cons. So, assembly language. What do we know about assembly language? It produces hex file easily, as you have seen it in the previous chapter. And it is much smaller than C. And the con about the assembly, when you write a large program, it is tedious and time consuming. So these are pros and cons about the assembly language. Let's talk about C. When compared to the assembly, it's less time consuming, much easier to write, and the con about it, the hex file produced is much larger. However, it is easier to modify and also update. And one of the important thing about the C is it's portable to other microcontrollers as well. So maybe with a little modification or maybe without any modification. So I will write that down. Portable to other microcontrollers. So there is no C specific to AVR. You are using embedded C, you just need to have some AVR instructions or the AVR registers that you need to use. And another good thing about the C, as you are all aware, they're pre-built function libraries. So you can use these libraries. You can use function libraries. So these are the pros and cons of assembly language. Now, in this course, I will focus on the assembly side, but in this chapter, we are specific about the C, so we are going to see all about the C in AVR. So let's see the outline of our lecture today. We are going to see the C data types, how we can create time delays in C, input-output programming in C, logic operations in C, and data serialization. So some of the important things that we already seen in assembly, now we are going to see them in C as well. Okay, so one of the goal of the AVR programmer is to create smaller hex files. So when we consider the C programming high-level language, as it is a cone for as a hex file produces much larger, we said, it is worth to re-examine the C data types. So we have to understand C data types. So let's see how these are used. So here is the table. We have got unsigned char, unsigned int, unsigned long, and so on. Now, when we talk about unsigned char, as the AVR is an 8-bit microcontroller, the char is a character data type, is the most natural choice for many applications. And it is giving a range between 0 to 255. So, or 00 to FF. It is the most widely used data type in AVR. So if you want to set a counter value, you can use unsigned char. And you can use it where there is no need for signed data because it's unsigned. And you can also use it in declaring variables. And we must be really careful over there because the size of the data and if you are going to use something unsigned, that is also important. So you might need to use int instead. And the AVR has got a limited number of registers and data RAM locations. Unsigned char might be useful. And using int, which is an integer, in place of char can lead to a need for more memory space. That's also possible because int is 16 bits. And we can also use unsigned char data type for a string of ASCII, including extended ASCII as well. Now, alternative to that is signed char. If you are desperate about the signs, an 8-bit data type that uses most significant bit, D7. So D7 to D0 represents the data, and minus or plus sign will be the value over there as well. So we have only 7 bits for the magnitude, giving us the value between 128 to plus 127, minus 128 to plus 127. And we can use in order to declare a quantity like temperature, minus 4 degrees. So we can use signed char over there. Unsigned int, which is a 16-bit data type in the range of 0 to 65,535, which is 000 to FFFF in hex. They are generally used to define 16-bit variables like memory addresses. They are used to set counter values which are greater than 255 that we cannot use unsigned char. We must not use the int data type unless we have to because it's large as a size. And also, registers and the memory access are in 8-bit chunks, so misuse of int variables might result in the larger hex files and slower executions or and the memory usage. So we have to be really careful on how are we going to use unsigned int. Then the signed int, which is a 16-bit again, And it also uses the most significant bit as the plus or minus sign bit, and 15 bits. That's why we have got minus 32,768 to plus 32,767. And long, which is a 32-bit. If we want values greater than 16-bit, we can use long. And for the float, for the fractional numbers, if you have fractions that you want to represent, we have to use float, and the double also used for fractional numbers. So you just need to know, and you just need to make sure that you know when to use which data type. Okay, this is important if you are going to be an embedded designer. As we are limited with the resources in embedded systems, we have to make sure that we are applying the most efficient way of coding. So this is important. Now, some things that we need to take care. Unsigned should be used for positive variables and provides wider positive range. And char should be used instead of int when possible, as it is an 8-bit variable and it allows smaller and faster programs compared to 16-bit variables. And we have to be careful that AVR has limited number of registers and data RAM locations. Okay, so let's see the first example related to this. It says write an AVR C program to send values 00 to FF to port B. Now, before I go into the coding, we might think about steps that we need to use or take care in order to implement this program or code. Now, what do we need to do? We have to define a counter, which needs to count from 00 to FF. So I'll say define. So we have to think about, are we going to use int, char? What do we need to use? Char is an 8-bit and it's just a counter that we want to define. We don't need a sign over there and we don't need a 16-bit because this is in the range. So I can just say define unsigned char for counter. Then what will be the next step? We have to set port B to be an output port. That's the second step. So as we have defined the counter, we have to loop through from 00 to FF. So loop from 0 to 255 or 00 to FF, whatever you want to call it. And then it has to wrap around, restart. Then what we need to do, we have to increment the counter as we are starting from 00 and increment. And then we have to end the code by using return 0. So different AVR compilers, they might have different header files. So when we are writing these codes, we have to define the header files based on the AVR compilers. So for example, if you are using WinAVR compiler, then we have to include AVR io.h header file. If we are using MicroSys Pro for AVR compiler, then we have to use built-in.h header file. So let's define the first program. Start with int main. We are not going to return anything, so we can say void. Then open the brackets. So we have to define unsigned char, let's say counter for Z. And then we have to set DDRB to be output. so 0 hex FF. And then we have to use a for loop that it has to count from 0 to 255. So we know the counter Z is going to be 0, and then Z is less than or equal to 255, then Z plus plus. So this is a typical C language loop for 4. So it will start from 0 and count up to 255. And then while it's counting up, we are just going to send this value to the output, port B, and then return 0. So that's all we need to do to implement this AVR C program. Now, when we consider this, so as I already mentioned it, if you notice it, this program never exceeds the for loop. So 0 to 255. So then why is it not exiting? Because as we are creating a wraparound over here, when it reaches to 255, okay, it's equal to that. We increment Z, Z will be 0 again, and it will start again. So this is going to be continue forever, and because the Z variable wraps around after 255 and goes back to 0 and carries on. Now, if you use micro C, how does the previous C code compile using the micro C Pro? I just want to show you the example of it. Now, this is the assembly, LDI, R27, 255, and so on. And this is how they are used. So int main void ddrb 0 hex ff R27 255 and ddrb R27. So assembly is given over there. And this is the loop. So we have to define it with LDI. The counter starts from 0 and then start address. Then it will have the 255, compare R17, which is the count, then do a conditional jump. Okay, so this is how we can see different compilers having some different instructions over there, or maybe you can see some, you can notice some other functions. And if you hit the assembly code, you can view the assembly code of the C program after the compilation. Okay, few things that we need to analyze. This is stack initialization. Okay, so we have to initialize stack as we are going to use some subroutines over there. Then port B configuration, like we have got it over here. And then defining the counter Z equals 0. And loop condition is given in the last statement. So over here, then you send out the Z value to port B. That's what we are trying to do. And then this will be incremented. And we check again, and we move the new value in there. And we send out, when everything is completed, this will be sent out. So return actually clearing the registers, return 0, okay? So they are cleaned up and ready for the next operation. And this jump is actually just waiting there forever. So this is how we can analyze it. And we have to make sure that every compiler is different. Some are more efficient than the others. Predicting the performance of design system requires some familiarity with the compiler. So if you are using, and if you start using Micro C Pro, keep going on with that. Otherwise, if you are just switching from one to another, it might cause you some efficiency problems in a way that you might confuse yourself as well. Okay, so here is another example, which the solution is also given over there. Write an AVR C program to send hex values for ASCII characters 0, 1, 2, 3, 4, 5, A, B, C, and D to port B. Now, we had to define some kind of array so that we can have all these ASCII characters in there. So my list is that array 0 to D. Then unsigned char, we define the counter, we set the port, then we loop 10 times, and then we increment Z, and we just send out each of these values to port B. Okay, so this is how we can use it. So we can say that define the list of characters in an array, which is that one. Define unsigned character for counter. Set port B to be an output port. Loop through the characters and send out each of those to port B. Okay. Now, another important thing that we have to make sure that we understand them are time delays in C. So we have seen time delays in assembly, and we have to consider them in C as well. So what do we know about time delays? Now, we can create time delays using a simple for loop, like counting from 0 to 255 is actually delaying what else you are going to do over there. You have to wait until it is done. Or in C, there's a good thing that you can use a predefined functions, or you can use AVR timers that we are going to see later on in order to count some time over there or create some delays in there. And when we are creating a time delay using a for loop, we must be mindful of two factors. One of them is the crystal frequency, which is connected to AVR. And they are really important factor in the time delay calculations. So the duration of the clock period for the instruction cycle is function of this crystal frequency. That is why it's important. And the second one, the second factor actually that we can talk about is the compiler. So some of the compilers are faster than the other ones. And when we program in assembly language, we can control the exact instructions and their sequences using the delay subroutines, for example, which we already seen that as well. Now, however, with the C program, it is the C compiler that converts the C statements and functions to assembly language instructions, because we are actually moving one step closer to the execution. Because in high level, so you create your code C, and then that has to be converted to some kind of ASM or hex code, and then hex code is generated. So what you are actually doing with ASM, you just directly jump to hex code instructions, but in C, the compiler converts it to ASM, machine language, and then to hex code. Okay, so this is important. Now, different compiler produces different codes, we can say, and if we compile a given C program with different compilers, each compiler produces different hex codes. So we have to make sure that it's not actually the program that is causing the delay, it is the compiler. Okay, another way of generating time delay, we can say, is the using predefined functions like delay 10 milliseconds. It's milliseconds, so you can just feed in the parameter as 10, so it delays 10 milliseconds. Delay 100 microseconds. So these are just predefined functions, and they might differ from one compiler to the other one. There is one drawback of using these functions is the probability problem. So as different compilers use different name or delay functions, you have to change every place in which the delay function is used. And this is because if you want to compile it in another compiler, so it's not actually portable over there. Okay, so we have to be really careful. Or if you are using a wrapper function, you just need to change the wrapper function and that's it. So another one is AVR timers, which we are going to see that we can use timer resources in AVR itself in order to count or time the operations. So method one, using for loop for time delay, as you can see, we can call a function, say void delay 100 milliseconds, void unsigned int, and try to loop 42,150 times. Okay, so this is how we do a delay with 100 microseconds using the for loop. You can use if, but there are some important things that you need to consider. The clock frequency can change delay durations. The compiler has direct effect on delay duration, and you must need to set the optimization level to actually 0, or we can say none, to avoid undesirable compiler optimization to reduce the delays. Now, one thing, again, that we need to be careful, the duration of the clock period for the instruction cycle is a function of this crystal frequency. So to omit the delay loop, we have to be, because we are wasting the CPU time, we have to omit that. So in Micro C Pro for AVR, you can actually set some optimization levels to 0. So this is actually helping you to optimize it, the time delays. So method 2, predefined, as I already mentioned, delay millisecond and delay microseconds are most often used. They are predefined functions, which you can find them in the util or .h header files. So these are actually doing all the calculations. You just need to call the function. That's it. So it's more practical. And as I already mentioned, portability problem might arise because if you are changing the compiler that you are going to use, then this will be a problem. Now, portability, in order to overcome the portability across different compilers, we can use macro. Do you remember the macro? So we can use some kind of a macro that, okay, delay millisecond, get some parameters, that will be our macro. Okay, so to change the compiler, you need to change only a simple function, like delay millisecond is a generic C function, and delay microsecond can also be used. And by they are compiler specific functions, and that needs to be modified. Only one line of code when moving to a different compiler. So this is something that you need to do if you're changing the compiler. So here is another example. Write an AVR C program which continuously reads the logic values on port B and writes them to port C. So again, the steps: we need to configure port B as an input. Then we need to configure port C as an output. Then we have to do loop continuously. Now the next step is attach pin B to pin C as an output, and then return 0. Okay, so let's write the code for it. Int main void and we have to write down, so set port B DDRB to be 0 hex 0 0, then DDRC as 0 hex FF. So we want port B as an input. So the comments are // and DDRC, it's going to be port C as output. So we set them up. Now, next thing that we need to do, loop continuously. So while one is the function that we generally use in order to loop continuously. And I have to open another curly bracket here. So I have to make sure that, okay, so that is one. So while one, port C is pin B. That's what it is. And then return 0. Now this is how we can write a C program which is continuously reading the value of port B and writes them to port C. So if you have questions about these, please note them down and feel free to ask them during the live session. So that's the C version of it. And that's the AVR assembly version of it. As you can see, you're writing more lines of code, but in the end, you can see how C is just few lines, but assembly is more direct. So you can define everything one by one in assembly. Okay, so that's the time delay. Now, next thing that we are going to consider is the byte-size I/O programming in C. So one of the most important and powerful features of the C language is its ability to perform the bit manipulation. And let's start with bitwise operators or byte-size I/O programming in C. So what you can see over here as a typical example,
port B is configured, then we are looping continuously, and we are saying, then we are sending out FF, we are delaying it 100 milliseconds, and then we are sending out 55 and delay it again. Now, in order to access a port register as a byte, we use the port X label, and we access the data direction registers in the same way, like using DDRX, and pin register use pin X. And as we already said, different compilers have different syntax for bit manipulation, and making it is the best way. So while you are getting familiar with the logic operators and or not, you might not be familiar with the bitwise AND, bitwise or XOR inverter, shift right or shift left. And they are widely used in software engineering and so on. And one of the important thing in order to make portable code, uh, which can be compiled with different compilers, we must use and or bitwise operations. So let's see the example over here. So 0b is actually a binary number given, and it's masked with which is a bitwise operation with 001. And true, it will give you true. So where we have got ones, the output will be ones on both. Otherwise, it will be 0. So if you are using or, then true or false still going to be true. And not operation is just inverse of true. That's so how we can use the bitwise operators as well. So if we look at an example over here, bitwise logic operators for C, AND operation, OR operation, XOR, which is an odd function, and inverter. So 1 and 1 is 1, but as rest is 0, rest are 0, these are all zeros. Or if any of them is 1, the output is 1, and invert, as you can see, 1, 1 becomes 0, 0, 0 becomes 1, and so on. So this is one's complement method of it. You can also do this with the numbers. You can write hex, you can write binary numbers, and you can still do that. Next thing is the shift operations in C. So data can be shifted to the right with number of bits or shifted to the left with the number of bits. So we have to specify that number of bits. So for example, in this one, now we have got 1, 1, 1, 0, 0, 0, 0, 0, and we are shifting right 3 times, it says. So 3 times means that has to be start from this one because these are all shifted out. That one becomes the first 0. That one will be the second 0. 1, 1, 1. And then those 3 shifted out, new zeros will be shifted in. And shifted 2 places to the left means this one becomes 2 places to the left. So 0, 1. Okay, so 2 zeros are shifted in this case. And another flexibility with the C, like with the AVR assembly as well, we can use OR operator to set bit of a byte. That's also acceptable. So you can use OR equals, and you just specify set bit 4
which is the 5th bit of port B. Okay, so you can do that with this instruction. Or in micro C, that will be like assembly. So port B, B4 is going to be 1. So you are setting it. You can also have AND operator to set bit of a byte to 0, which we are saying is a masking. So and invert 1, so clear bit 4, which is the 5th bit of port B. This is what this example is doing, because we are just using the inverse over there. Don't be confused. Or in micro C Pro, port B B4 equals 0. So as you can see, these might differ depending on the compiler that you are using. Another thing is, how can we check a bit in a byte? Again, we can use an AND operator to see if a bit in a byte is 1 or 0. And this is how it is done. So as we are ending everything, so we can send out, we can see when it is going to be 1. So by ending it, we can easily observe that. Okay, so data serialization, we have got two methods in order to serialize data. USART, which is a special resources in AVR, which we are going to see that universal serial port, and SPI, I2C, and GTAC, and some of these are going to be covered later on in this course. And or we can use parallel port to send bits serially like a manual method. Okay, so these are all alternatives. Now there are some C examples that we can go through together, but I'm leaving that for live session. So let's see an example of data serialization. It says, write an AVR C program to send out the value 44 hex serially 1 bit at a time via port C, pin 3, and the least significant should go out first. So the steps for the program: write AVR C program to send out the value 44H serially 1 bit at a time via port C, pin 3. First, we have to define 44. Then we have to define temp data. Then we have to define a counter. Then set 44 as temp data. Then we have to configure port C to be an output. And then loop 8 times. Sorry, 8 bits to serially, because we need to send 1 bit at a time. And while you're doing that, check temp data, least significant bit is 1. If yes, port C pin 3 is going to be 1. If no, port C pin 3 is going to be 0.
and we can then shift it right one time. Okay, so let's write down the code. Int main, again we are not returning anything, so it's void. Now we have to define unsigned. 44 can be defined as unsigned char serial data, which is equivalent to 0 hex 44. Another unsigned char. If I'm not desperate about the data types, I prefer to use unsigned char most of the time, as it is more efficient. Unsigned char temp ser data. So temp data has to be defined. Then counter unsigned char z. And then we can say temp ser data equals ser data. So as you can see, hex 44 is our temp value. Okay, so we are over here. Then DDRC. Now this is tricky. We are actually ORing and shifting. Okay, so one bit to the left. So we are actually configuring port C pin 3 as an output. And then what we need to do, we have to create the loop for x is equal 0. And then x less than 8. We are going to shift out 8-bit serially. X plus plus. And then in the for loop, what we need to do is we have to check if temps or data so looking for ampersand. Okay, so temps or data ended with 0 hex 01. So this is actually means that we have to check this significant bit. Then we have to set port C as the first serial pin. So this is actually telling us that set port C pin 3 to 1. Else port C is going to be the inverse it's really difficult to find the tilde, so that's going to be inverse 1 serpin shifted. Okay, so we can use it that way.
So I'll put port C down here, and this is going to set port C pin 3 to 0. And then finally, temperature data is equals temperature data 1. So this is actually means shift to check the next bit. So as you can see, like we have done in assembly for the IOs, for the data serialization, we can easily do that with C programming as well, maybe with less instructions. Okay, so we have introduced C language for AVR. You can find more details in the book. You can also find some examples in the book related to C programming if you want to write a C code. Um, as I already said before, I prefer to use AVR assembly, and in order to learn assembly language as well in this course, it's more important, I guess. And you might also get questions from C as well, or if you want to create a project, you can create your project in C, but AVR assembly is also going to be considered in most of the lectures. Thank you.